Over here for the substitution elimination problems and so on, pages 8 and 9. So these problems all have these things in front of them. Doesn't really matter, it just indicates this group together. All right, for substitution, this is going back to, most of you did very well on the testing and stuff, which was great. So I'm hoping that these three problems won't be too bad, especially considering what you've been doing most recently in class. These two variable equations shouldn't be too bad at all. It's the three variable ones that are a little long. So substitution, we haven't used this one in a little while. You're actually sticking one equation into another. You're looking for it to be solved for a variable like this. So when y is by itself, it's telling you that y can be replaced with 2x minus 1. So what you're going to do is take that 2x minus 1 and stick it in for y in the other equation. So literally you'll rewrite the other equation exactly how it is, except where the y is, you'll put in parentheses 2x minus 1, and then continue rewriting the equation as it was. What you've done is, while it seems like initially you made the equation more complicated, you've actually taken the y variable out of it. So this is something you could actually solve with a little bit of work. So we have 3x, but then this needs to be distributed, so you have 4x and negative 2, all equals 26. Then combine like terms a little bit here, I have 7x minus 2 equals 26. And now I'm just going to do some simple solving. I'll add 2, get 28, and I'll divide by 7, I get x equals 4. Okay, so with our answer for x, you're not done though. You have to come back up and put it back in here so you can get y. You guys should be really familiar with this by now because you've been doing it a lot with the 3D substitution. So take this answer for x and come back here. If you look at it, it's actually really easy. Put the 4 in here, you're going to get 8 minus 1, y is equal to 7. So you should write your final answer as a coordinate point, 4, 7. Okay, this problem should be even more familiar to you because you've been doing a lot of work with elimination with 3D variables. So 2D again should seem like nothing by now. These two look like they would cancel if you add them together. That's what you're looking for. So we're going to actually add each column of this together. You're going to get 6x, these cancel, and 34 plus negative 4 is 30. 6x equals 30 divided by 6, x is 5. That's that. Okay, now you have your answer for x. You've got to take it back up to one of these original equations. I'm going to choose the one without the negatives in it, because why not? And stick your answer in for x. So what I really have here is 2, and then, remember, x is 5 now. And then I have plus 3y equals 34. So this is 10. 10 plus 3y equals 34. I'm going to subtract that 10 off. I got 3y equals 24. And then I'm going to divide by 3. I get y equals 8. So our final answer is 5, 8. No problem. Okay, some of our newest material here. We're dealing with 3D stuff. This is our most recent thing. Okay, 48 asks you to graph a 3D point. These are the ones where you'll draw the tail diagram with it. Remember that we now have x here, y here, and z here, and that out here is negative y, out here is positive y, this is positive z, negative z, negative x, positive x. Okay, so how do I graph negative 2, 3, 4? Well, I look at this as like 3 directions to where to put a point. This to me says go into the board, or in other words, this way, 2 places, then go right 3, and finally down 4. So if I'm going to trace this out, here's the negative 2 part, estimating point. Back this way, negative 2. Then I'm going to go right 3 places, literally 3 places to the right. We'll make it a little bit longer than that. That seems reasonable. And then down 4. Again, estimating the location somewhat there. I'll put a point there. And that's my final spot. So if your point is a little bit off from the one I drew, it's no big deal. That's just happens to be where I kind of estimated it to be. All right, this one is a little bit different. 49 is an equation. Remember when you graph an equation for a 2-variable thing, it's a straight line. When you deal with 3 variables, it represents a plane or a surface like that. So you do it the same way though. We have all of these terms equal to 4. We want to find the intercept for each. So I'm going to say x equals 4, negative y equals 4, and 2z equals 4, like 3 small problems. This one is solved already, so I can go ahead on the x-axis and put where I think 4 is, probably somewhere down here. That's one of the points I'm going to graph. This one needs to be solved a little. I'll just divide by a -1. Y equals -4. So on the y-axis, I have a point at -4, which would be out this way somewhere. And finally, divide by 2, z equals 2. So on the z-axis, I'm going to go up 2 places. It's going to be like right there. Okay, so I have my 3 points drawn in, and this seemed to be where everybody had so much trouble with it. Drawing a plane, you want to connect these 3 dots. This doesn't have to be perfect, but it should be kind of accurate. So you have that side of it. You want to draw the other side parallel to that one. Something like this. So that you have parallel lines here and here. And then to indicate that it's a sheet, not a square, they often shade it in like this. That's your final answer for number 49. Okay, let's look at 50, our most recent stuff. You've been spending 34 days on these in class now, so I would imagine that you're probably pretty versed in it. So let's take a look at it anyway. All right, we're looking at a 3D elimination system here. So trying to figure out what you can do with this. What you really want to happen is you want the same number in front of all the x's, y's, or z's, one or the other. To me, I would think that because y already has a 2 in front of both of them, I could make this y a 2 also, and that would be enough. So that's my tactic for this one. I'm going to choose to cancel out the 2 or the y. But all I need to do is multiply this one by 2, and these two all leave the same. So my new equation here will be 2x plus 2y. You really need to take your time with these, plus 4z equals -4. And then I'm going to use the 2 other equations that I have above it. So in this case, I'm just going to rewrite them. And a lot of people don't like to do all this work of rewriting it. It must be awful. But it's pretty necessary here to keep this stuff straight, I think. So I'm just rewriting those other 2 that I already have. So the key is when you've got this set up to solve it, one of your variable terms, in this case for me it's the y, you should have all the same number and one of them should be opposite sign of the other. So they're ready to be combined now. We're going to run out of room here, but I want to write this over here. What I'm going to combine is, because I want these 2 to cancel, I'll combine those 2. So I get, just adding like we're eliminating, 3x, the y terms cancel, and I get -2z equals 5. And then for the bottom one, when I do the second equation, this time I want the -2y to cancel the +2y of the other equation. So these 2 I'm going to put together. I get 4x, y's cancel, I get 5z, and I get 3. Okay, I'm going to take those 2 equations, I'm going to rewrite them over here just to keep my problems straight. if you have your paper there and you're following along with this, or you're checking your solution, I tend to tell people to turn their paper sideways or landscape so that you have a lot of room and you can write this horizontally. To me, it makes it a lot easier to do it that way. These are two equations that we have. See, the problem is you want to cancel something again, but in this case, neither equation really has something easy to cancel. So, you know, I could choose to cancel the x's or the z's. It really doesn't matter. I think I'm going to cancel the z's because I see a negative and a positive here that if they were the same number, I could get them to cancel. So I'm just going to multiply this one by 5 and this one by 2. So this one's going to be 15x, negative 10z, and 25. And this one is going to be 8x, 10z, and 6. See, now I have something that I can push together and get it to cancel. So I'm going to do that step finally. Right here, put them together. And I get 23x equals 31. See, I'm going to look at that and say to myself, something doesn't seem right. What would that be? Because when I do this, I'm going to get a number that doesn't work out very nicely. And I think most of these tend to. So I'm a little curious as to what happened with this one. Let me go back and check my work for a minute. And I can see what it is already. It's all the way back here. This is the kind of stuff that happens when you do this. So you need to be patient. It even happens to math teachers. Back here, I forgot. 2 times a negative 4. Right here, I forgot to multiply, so it should be a negative 8 there. I'm going to fix that. We're just going to do a little editing to this problem. Negative 8 here. So when I combine them in this step, the 4x is okay, the 5z is okay. But this is now a negative 1. And so that means over here, this 3 is not a 3, it's a negative 1. So we got to fix that. It also means that this is not going to be right when we do this. So we have a negative 1 in here. So if I go back and look at this again, I have 2 times 4x, that's 8x. 2 times 5z is 10z. 2 times negative 1 should be a negative 2. And so finally, when I combine these, I do get to 23x. I get these to cancel. But over here, I get 23. That makes it a lot better. X is equal to 1. Don't panic. All right, so with x equal 1, we got to go back up and find an equation that only has 2 variables in it. So I have this one. I'm going to come back with my answer correct. I'm going to go back over here and say, all right, well, I'm going to use one of this. I'm going to use the orange one because it doesn't really matter. So I'm going to say 4, and then I'm going to put my 1 in for x, plus 5z equals negative 1. That's equal to 4, and if I subtract it off, I get 5z equals negative 5. When I divide, I get z equals negative 1. So I have x, and I have z. I'm going to take my 2 answers and go all the way back to the beginning. I'm going to pick the easiest one of these problems to deal with, which to me looks like the bottom equation. And I'm going to put it all back in, put my answer for x, my answer for z in, and get an answer for y. So I got 1 plus y plus 2 times, well, z is negative 1, all equals negative 4. So I got 1, and I got negative 2, that's negative 1. Y minus 1 equals negative 4. I'm going to add that and I finish with y equals negative 3. So your final answer to this problem would be x is 1, y is negative 3, and z is negative 1. Well, the color looks sort of like a Rembrandt or something. All right, last one. Again, we have one of these 3D systems. And I'm looking at it, trying to figure out what would cancel the easiest, the x's, y's, or z's. I guess y's have pretty low numbers, but I got a negative 1, a 2, and a 3. That's kind of a mess. I guess I could do the x's. I could turn them all into 6. But I like the z's here. I can turn them all into 4s. That would work a little bit better and easier for me. I'm going to multiply these to get them all to be 4, but I also have to make one of them negative. So I'm just going to go ahead and make this middle one negative by multiplying it by negative 4. And the bottom one, I only got to multiply it by 2. So we're going to get the same equation on the top that we had before, because we're not doing anything. 6x plus 3y plus 4z equals 3. So the new equation here is going to be negative 4x, negative 8y, negative 4z, and negative 12. And the bottom equation will be 4x, negative 2y, 4z, and 2. Now we're ready to combine them together, so let's do that. Looks to me like these two would cancel. I'm going to put the top two together. That's going to give me 2x. The y's are going to give me negative 5y, and the numbers are going to give me negative 9. And then it looks like I can put the bottom two together. Here, the x's actually cancel, which is great. Negative 10y. The z's cancel, which was our plan, and we get negative 10 from the numbers. So it's wonderful in this problem that we don't have to go through all the work of doing another elimination step. We have one equation where we actually got to eliminate two variables at once, which is fantastic. So what we're saying is negative 10y equals negative 10, well, y must equal 1. So we actually get y, we get to skip a step here. So here's the thing, with y equals 1, I'm going to go back to this orange equation right here and put a 1 in there and solve it for x. So this problem is going to be so much shorter. It's 2x minus 5 times 1 equals negative 9. Because I put the 1 in for y. So it's 2x minus 5. I'm going to add 5 to make it 2x equals negative 4. And I divide by 2, I got x equals negative 2. So I have y, and now I have x. I'm going to go back to the beginning. Pick the easiest equation I can deal with. To me, it looks like the middle one. All positives, all low numbers. Why not? And substitute those in to get the final one we're missing. So I'm going to say x, which is negative 2, y, which is 1, so 2y, 2 times 1, plus z equals 3. So I got negative 2 plus 2, which is 0. I end up with, without even really doing much work, z equals 3. Look how much shorter this problem is compared to some of those other ones. You never know what you're going to get with these things. Let's write the final answer. Negative 2, 1, and 3. So at this point, that's the end of the whole running test review, which we're actually going to move to Thursday, December 8th, instead of Wednesday because of our 2-hour delay schedules. And so I want to give you a bonus grade for this one. So if you're watching these videos, good for you. Let's say the bonus grades for the test believe 3D systems are a work of art.